All right, thank you to whoever posted the link. So we've given you sort of a whirlwind tour of Neuron and things that you can do with Neuron. Wanted to highlight that there's a number of other resources that are available that can help you with your Neuron models. So of course, there's tons of stuff on Read the Docs about Neuron itself. But just to highlight a few other things besides Neuron that are eminently useful. We've used GitHub for sharing our slides today. We use GitHub for Neuron development. I strongly encourage you to consider using Git and GitHub for keeping track of version control, even if it's just your own little project and your own little modeling thing. It'll allow you to see, so version control lets you keep track of all of the changes that you make. So you can go back to, it worked yesterday, why doesn't it work today? Well, what was the code like yesterday? And that change that, and you can find that change that you made that shouldn't do anything that actually did do something. So Git allows you to do that, and also makes it much, much easier to collaborate with other people and share code. And GitHub is just sort of a front end for that, which I guess you all know since you found the slides. Ted, would you like to say something about the Neuroscience Gateway?
Well, yes. It was developed initially to support people who are engaged in computational modeling of cells and networks, who are having problems getting their code running on local, that is to say in their lab or their university or other institution hardware for various reasons. And the approach we took was to make it exceedingly easy for people to run their code on NSF-supported high-performance computing resources. Since then, it has expanded considerably in its scope. It now is, excuse me, it now has a facility for doing intensive large-scale data analysis, and facility for accepting very large data files, moving files around. And it also has a now a under development resources to be used for development and dissemination of neuroscience software by other people who are working on their own tools. So you can see there's a wide range of tools available on the Gateway. It's very easy to get an account. We just want to make sure that you're not a hacker and you have some kind of a legitimate research approach. We don't want to be doing people's password cracking for them or Bitcoin mining. And we give you free time and enough to get you started. And if you decide you really need more time and you're being productive with it, we'll even help you write your own allocation request to get a lot more time from NSF. NSF's the outfit that supports the nation's academic high-performance computing resources. And that, I think, is, it's a lot of people have already published results that were generated on NSG's resources. Again, it's pretty simple to use. And you can use it through the GUI, that is via browser, or you can use it through scripting over the internet. And if you want to find out more about it, just go to nsgportal.org and see what you can do. That's it.
Right. Thanks, Ted. Do you want to say anything about LFPI since I've got you?
Well, LFPI was developed by a bunch of Norwegians who, in the long, dark, cold winters, decided they needed to develop more powerful software for doing simulations of extracellular stimulation and recording from cells and collections of cells, networks, etc. And it's they have some papers out about this and a growing number of papers that have published results generated using LFPI. It is a Python module that makes use of Neuron, and it is extremely high quality work, and I commend it to you if you are interested in extracellular fields. You can always do your own, roll your own, but if you're looking for something that's up and running and you don't want yet another project because you have enough of your own and you just want to use something that runs, I would recommend go ahead, use LFPI.
And I'm not sure, but they might have a INCF tutorial later in the week. You should check it out if extracellular potentials is a thing that's of interest to you.
Good point.
So also, one of the other things that's coming as a challenge, so how do we actually identify what the right parameter values are? A lot of times, you probably don't want to minimize the error in the 2 norm. So in the traditional curve fitting is not necessarily the right thing to do. How do you choose parameters in a high dimensional space? It's a hard problem. Neuron does include what's known as a multi-run fitter tool that you can use for parameter fitting. But one of the great things about Python is that you can just as easily use any other optimization algorithm that's out there. So in particular, I want to give a shout out to the Bluebrine project that developed BluePyOpt, which is a package that makes it easy to use genetic algorithms and other fitters to optimize neuron models specifically to match the kinds of properties that various kinds of electrophysiological features. So maybe not fitting the trace per se, but maybe certain characteristics of a trace, like the half width or the rise time and amplitude. So these are the kinds of things that BluePyOpt is especially apt for. Speaking of electrophysiology features, I believe this is also from the Blue Brain project, is EFEL, the electrophys feature extraction library. So for example, if I have T and V being neuron vectors of time and voltage, then I can use EFEL to, for example, here get the action potential amplitude, the inner spike intervals, the spike half width, and the begin time of each action potential. You could do all of this stuff yourself, but why? When these tools also exist. This, by the way, there's nothing inherently neuron about this. This is just the kinds of measurements that I might want to make on any sort of electrophysiology models, whether I'm doing this in silico or with an actual animal. Relatedly, you might also be interested in Elephant, which definitely has a tutorial together with Neo, INCF CNS tutorial together with Neo on Friday morning in European time, very, very early for those of us on the US East Coast. But so this is an electrophysiology analysis toolkit. So again, not restricted in any way to computational neuroscience. You can use it in the wet lab as well if you want to use it to measure, like, so maybe you might, we use it in my lab to compare spike trains. And so you can do things like the Van Rossum distance between 2 different spike trains, whether they're real or simulated. Elephant is a tool for that, has everything that you need. You don't have to code any of it. Also want to give a shout out to NeuroML, which is an attempt to develop a standard for interchange of computational neuroscience models. And so there are a number of models that have been converted to NeuroML. And so if you do have a NeuroML model, you can convert that to Neuron using the PyNML package, which you get from the NeuroML website. So PyNML and then the NeuroML model -neuron will translate that interchange format into a regular neuron model so that you can then run simulations, do analysis on it, etc. Um, Also want to give a shout out on I guess this is back to electrophysiology. If you want to actually know data, neuroelectro at neuroelectro.org is a great source for getting data and finding out, well, wait, what should the resting membrane potential of a CA1 pyramidal cell be? Well, spoilers, it's a wide number of values in the literature, and neuroelectro tries to collect them and show you what values have been measured and under what conditions, and all of that. That's all there. You can go and see various properties for a large number of cell types. So this is all sort of the raw values, but they do point you to the articles where they get their data from, so you can go and see if everything is relevant for your use case. I'll also point out CRCNS is a raw data exchange site for neuroscience data. Sometimes there's interesting data sets there that might be of value for your simulations. I want to talk about, I gave a shout out to pandas earlier. I mentioned about as far as saving and loading data. You can load data to CSV. You can also save data to a database. So I do this, for example, if I'm running a long running parameter sweep and I just want to be able to, I'll just save every piece of data, I'll run my data, I'll record it, and I'll use pandas and SQLite 3, which is built into Python. Don't have to do anything. Pandas is a separate install, but it comes with like Anaconda. And I can just dump all my data to a database. When it's in a database, it's relatively safe. I don't have to go back and worry about it disappearing. I don't have to worry about file management. And the nice thing is I can have one code maybe running on an HPC that's generating this and populating this database. And then I can just go back and I can have another code base that plots the stuff. And I can see, well, okay, I'll just plot whatever I've got so far. Is this looking good or not? I don't have to wait until everything's done to see how it's going to look. I can do that sort of asynchronously, and I can have this separate database. And I find that's an extremely helpful workflow to have in my personal experience. And finally, in terms of related resources that you might want to look into, netpine is a Python package for development, parallel simulation, optimization, analysis of biological neural networks using Neuron. Well, okay, well, we're already talking about using Neuron. Sure enough, we didn't do very much about networks. So if for no other reason, that might be of interest to you, but certainly you can, and most people do, build their networks directly in Neuron. But netpine is a level on top of Neuron that's designed to make it easier and to provide certain ease of analysis and some certain things that are available. So directly, you see in this picture, right? They're directly looking at the correlations of activities of different cell groups. So that's all right there. There is an INCF CNS tutorial tomorrow on netpine if you would like to know more about that. And again, all the simulations are run with Neuron. So the nice thing is about that is if netpine itself doesn't directly support whatever you want to do, it provides the ability for you to just write in raw Neuron to supplement your netpine description. So that's another thing that you may want to consider. So that's all I really had about sort of other resources that I wanted to highlight. Certainly there are more things that are useful to computational neuroscience. Ted, did you have any other things that you want to bring up or closing points?
Well, with regard to netpine in particular, how easy is it to accomplish things outside of the scope of netpine if you have to write your own Neuron code?
I suppose that depends on who you're asking.
Yeah, I mean,
So
the reason I ask is the usual person who wants to use netpine doesn't know much Neuron code, and then when they need to do something special, they kind of have to wait for Salvador to do it for them. I mean, that's what I've seen. I don't know. Maybe there's people who are more resourceful and are using it right and left and enhancing it with their own their own code that does the special things they need. It's under active development and it's improving all the time. I don't know what its current scope of, quote, what's easy versus what ain't so easy is. But if you're not familiar with Neuron and you go to netpine, you're going to find yourself then having to deal with code that you don't really, when it comes time to trying to get around netpine with Neuron, you're going to have to learn an awful lot about advanced Neuron topics that that are going to be like isolated from anything else you know. I don't know about you, but it's generally difficult for people to learn things in isolation of other bodies of facts because you don't have the hooks to link them into your associative memory system. So I don't know how that works out in practice.
It's a tool that some people find useful, and some models have started to be published with it. So
Yeah, a lot of
I'm gonna
people
give it a
are
shot.
very productive with it because it does exactly what they need, and that's great. And again, it is under active development. And if you're doing something that it can't do, and that's an important something, then I bet that netpine's developers will start focusing on that, and before long, it will do that as well.
Fair enough. Any other parting thoughts?
This is just a sort of a almost too superficial survey of Neuron's capabilities. We have in our multi-day course, which we kind of took a break from when travel was so difficult, et cetera, et cetera, et cetera. We had much more opportunity to get into great depth with things and to have hands-on activities for you because you really learn this stuff when you're writing it yourself. There's no substitute for busting your chops on a problem and learning that way. And
So if I can
go ahead.
if I can just point out, so on the Read the Docs site, we do have a link to Neuron course exercises. It has, I think, 18 different sets of exercises ranging from everything from the cell builder, in-modal files, loading model DB, Neuron scripting. So these are all things from an in-person course that we gave back in 2018. If you would like to try your hands at them, and again, as Ted said, this is just a whirlwind overview, but it's certainly worth trying your hands at. I also want to point out under the training videos, there's the Neuron 2021 online course, which is the 32 hours of material that was delivered over the span of 2 months last year. This is obviously a much slower pace, and we were able to actually discuss and do exercises in a way that was difficult here. So this is all information is available on Read the Docs as well, if you would like to check it out.
Okay. Well, I'd like to thank everybody for attending, and we appreciate your interest in Neuron, and we're glad to receive any feedback you have if you continue to work with Neuron. Questions, please feel free to sign up with the Neuron Forum, and that's our usual mechanism for providing support, although we do respond to direct email as well. And if you do happen to publish something that reports work done with Neuron, please be sure to cite Neuron. And we'd be glad to hear from you and see how you're doing things, especially if they're things that are expanding Neuron's realm of utility.
All right, thanks so much, everybody. I'm going to stop the recording now. If anybody has any other questions, by all means, I'll hang out for a little bit. Otherwise, I wish you the best of luck.